problem 2.1, sorry. Determine the domain of the following functions. Okay, so we have 8 functions here, and as you can remember from theory, the domain is the set of, well, real numbers in this case, where a function can take its values. Okay, and a way to think about it is to think of all the valid x numbers that we can plug here, so that something is given in return. So we have to find all these sets for these functions. Okay, so let's start with the first one. So first is f of x is 1 over x squared minus 5x plus 6. Okay, so this is a rational function, and we know that the domain of rational functions are the whole of R, okay, the real line, except those numbers, those values of x that make the denominator be 0. Okay, so in this case, we have to find the values of x that makes this equal to 0. Okay, and we have done this before. So this is a second order polynomial, and you know how to solve this thing. There are 2 solutions, 3 and 2. So the domain here is the reals, okay, every real number except 2 and 3. Okay, so this is the set that is contains only the numbers 2 and 3. Right? Okay. Next one. 2. F of x is the square root of 1 minus x squared plus the square root of x squared minus 1. Okay, so here we have 2 conditions. First, we need to have valid numbers for this square root and valid numbers for this square root. Okay, we know that the domain of a square root is that its argument has to be greater or equal than 0. So first condition is that 1 minus x squared is greater or equal than 0. Okay, otherwise we don't have a real number out of this. If we were talking about complex functions, this would be different, but in real functions the square root is only defined for positive arguments. So this has to be greater than 0, and this has to be greater than 0. Okay, but the interesting thing is that this expression we can write as this if we multiply everything by minus 1. Okay, or just put this in the other side. So that means that 1 minus x squared has to be greater or equal than 0. 1 minus x squared has to be smaller or equal than 0. Or in other words, 1 minus x squared. The only way to combine these 2 expressions is that this thing is 0. Okay, but 1 minus x squared is just x squared equals 1. So x is either minus 1 or 1. Okay, so the domain of this function is just minus 1 and 1. Okay, any other number will give you an invalid outputs for these functions. Okay, so that's it. And yeah, it's not a very interesting function indeed, but that's why it is. 3. F of x is 1 over x minus 1 minus x squared. Okay, again we have a rational function. We want to find all the values that make this 0. So these values will be out of the domain, but also we need to have valid input for the square root. So that means that 1 minus x squared has to be greater than 0. So this means that 1 minus x squared has to be greater 0, or in other words, x squared has to be smaller or equal than 1. Okay, and this means that x has to be in this interval. Okay, so that the domain will be contained. So if we write it in set theory terms, the domain D will be contained, so that means that this symbol means that D is a subset of this interval. Okay, so it's something between -1 and 1. Now we have to solve this thing. Okay, so D will be this interval without the values that make this 0. Okay, so let's do it here. This means that this will be 0 when these two things are equal. We can square both sides, and then we have 2x squared equal to 1, and then x is equal to the square root or plus minus square root of 1 over 2. Okay, so x, you can write it again. So now trick or attention here. When we had this equation, we squared it, and now we are including extra solutions. Why? Because this equation is also the square of this one, x minus. Do you see? If we square this one, we also lead to this one. Okay, but as you can see that this equation and this equation, which is this one, okay, this one is this, these two equations do not have the same solutions. You see, right? They're not the same equation, but when we square them in order to solve them, we get the same equation. So this x are the solution of this one. Okay, but that means that one of them will be the solution of this, and the other one will be the solution of this. Okay, so we just need to check. In this case, what we have is x positive here, and then the result of this will be a positive square root. So the solution that we're looking for is x is 1 over the square root of 2. Okay, and minus 1 over the square root of 2 is the solution to this equation, but this we don't care about because this is not the one we have here. Okay, so now we know that this belongs to this, sorry, it's contained in this interval without this point. Okay, this is the only point that makes this equation be 0. Okay, if you don't believe me, you can substitute x equals minus 1 over the square root of 2 in here, and you will see. Okay, it's easy because yeah, you don't really, you have minus and then minus, so you have a negative number here, so don't worry about that. So D is this interval minus this point. So in other words, this goes from -1 to 1 over the square root of 2 open union 1 over the square root of 2 1. Okay, this is the domain. All right, now let's do 4. F of x is the square root of 1 minus the square root of 4 minus x squared. Now again, we have two conditions. The first condition is that 4 minus x squared has to be greater or equal than 0, and then the second condition is that 1 minus the square root of 4 minus x squared is greater than 0. Okay? These two things have to be fulfilled at the same time. So, okay, so this one means that x squared has to be smaller than 4, and this means that x belongs to this interval -2 and 2, right? And this one means that, okay, let's see, 1 is greater or equal than the square root of this. Again, we can square both sides, and now because these two parts are positive, if we multiply them by themselves, the sign, the direction of the inequality doesn't change. Or in other words, we can say that x squared has to be greater than 3. And so if you think about it in graphical terms, what it means is that you have parabola. Sorry. Whoa. I'm really bad at this. Parabola. Okay. And so it has x squared greater than 3. It means that you have 3 here. It's x squared greater than 3. It's all these numbers. Okay. So from here to this, and from here to minus infinity. Okay. And the value that makes x squared be 3 is square root of 3 here and minus square root of 3. Okay, but we know that x has to be between -2 and 2, so the domain is actually from -2 to minus the square root of 3, and then from the square root of 3 to 2. Okay.